In this video, you'll learn how to solve equations step by step, and we're going to use some physics equations so that when you are learning physics and you see these equations, you're going to feel comfortable in trying to solve for certain variables. In this first equation, we're dealing with energy, and we're going to solve for V, and V is the velocity. And first, you'll notice that there's an m on the left and an m on the right. And whatever you do to the left-hand side, we want to do to the right-hand side. So that's the key thing to remember here. So I can divide m on the left and divide m on the right-hand side. You'll notice that the m's will cancel out. That leaves us with GH is equal to 1 over 2 V squared. I want the V by itself, but there's a half 1 over 2, so I want to get rid of that. So I'm going to multiply 2 on both sides, and that gives me 2GH is equal to V squared. Notice that there's a square there, and I want to undo that. I'm going to undo that by taking the square root on the right-hand side and the square root on the left-hand side, and that leaves me with V is equal to square root 2GH. And I did switch these left and right. So that is our answer for V. Next, we're going to take a look at a kinematic equation and a part of a kinematic equation, y equals 1 over 2 at squared. This is dealing with motion and acceleration. And we're going to solve for t, which is the time. And so I want to get t by itself. I see that 1/2. I'm going to get rid of that. So I'm going to multiply 2 on both sides. That gives me 2y is equal to at squared. Next, I want to get rid of the a. So I'm going to divide a on both sides. The a's cancel out over there. That leaves me with t squared is equal to 2y over a. So we have 2y over a is equal to t squared. I'm going to square root. I'm going to undo that squared right there. So we're going to square root the t there, t squared, and that leaves us with t is equal to square root 2y over a. Next, we're going to look at a gravitational force equation, and we're going to be solving for r. And r is going to be represents the distance between the two masses here. So we're looking for r. Notice the r is in the denominator. I want to get that up. So I'm going to multiply both sides by r squared. So I'm going to multiply both sides by r squared. That gives me fg r squared is equal to big G times m1 times m2 on the right-hand side. Next, I want to get the r squared by itself, so I'm going to divide both sides by fg. That leaves me with r squared is equal to big G times m1, m2 divided by fg. And then to undo the squared here, I'm just going to square root both sides, and that gives me r is equal to square root big G times m1, m2 divided by fg. Next, we're going to take a look at a pendulum equation. This is the period. T is the period, and P is telling us it's the period of a pendulum. And we're solving for G, the gravitational field strength here. This could be different if you're on a different planet, but right now we're not focusing on that. We're just going to focus on how would you manipulate this to solve for G. So I notice that there's a 2 pi here. I want to get the 2 pi to the other side, so I get TP divided by 2 pi, dividing by 2 pi on both sides. That leaves me on the right-hand side, L over G. I want to get the G out of the square root, so I'm going to square both sides, and that's going to get rid of that square root. So I'm going to get TP over 2 pi squared, and that gives me L over G. Now notice G is in the denominator. I want to get it in the numerator, so I'm going to multiply G on both sides, and that's going to give me G is equal to, and then I'm going to divide both sides by this TP squared over 2 pi, so that's going to go on my right-hand side, so it's going to give me L, which is the length of the pendulum, times, and notice that I'm dividing this, so it's going to be flipped, so 2 pi over TP, and this is still squared. Now I can expand this so that it's 4 pi squared divided by TP squared, which this value and this value is the same thing, so you can write it either way. There's an L as well. Yep, there's an L there as well. Right. So once again, just remember whatever you do to the left-hand side, you need to do to the right-hand side. Now we're going to take a look at a focal length equation. You can use this for lenses or mirrors. And we're going to solve for dI, solving for dI here. And you'll notice that there is this 1 over dO. So I want to get rid of that. And I'm going to subtract 1 over dO on both sides. So that leaves me with 1 over F minus 1 over dO. On the right-hand side, that leaves me with 1 over dI. Now, I want to be able to subtract these two fractions, but I need them to have a common denominator. So the common denominator will be f dO. So in this fraction, whatever I multiply on the top, I'm going to multiply on the bottom. Whatever I do to the top, I'm going to do to the bottom to keep this fraction the same value. So on the top, it's going to be dO. I'm going to multiply the top dO. The bottom will be multiplied with dO as well. And then this fraction, I need to multiply the top with f, and then also the bottom with f. And now I have a common denominator and I can subtract them. So now I have dO minus f all over f dO is equal to 1 over dI. Next, I'm going to get dI by itself. So I'm going to multiply d on both sides. So I'm going to get dI on this side. And then this, I'm going to divide this on both sides. When I do that, basically, I'm going to flip it over. So I'm going to get f dO over dO minus f. If that kind of bothers you a little bit, here's another way to think about it. So another way to think about it is I can cross multiply. So I have dI times dO minus f is equal to, and then cross multiply there, I get f dO. And then once again, I'm looking for dI, so I'm going to take dI is equal to f dO divided by dO minus f. So here I'm just doing it step by step just to make it clear, because if I go here, it's not very clear. I jumped some steps there, but hopefully this way it's much more clear how I got to this point. Next, we're taking a look at the critical angle equations when we're dealing with light. And it says sine theta c, critical angle, equals n2 over n1. And in this problem, we're looking for the critical angle. So how would you solve this? So in a problem like this, we're going to take the inverse sine. By taking the inverse sine, that's going to give you the angle, the variable that's in this parentheses. So we're going to do the inverse sine, so we can write it this way. Sine, the inverse, this is the inverse sine, times n2 over n1. And on the calculator, I'll show you in the next video how to calculate that, but that's how you would solve for the critical angle here. Now we're going to come back to another equation of motion equation. It's actually the same one we saw earlier, but in its expanded form. And we're going to solve for t. We're going to be using the quadratic equation for this. And so I want to be able to write it in this form. So ax squared plus bx plus c to be able to use a quadratic equation. So my game plan is I'm going to move the x to one side, and the other side is just going to be 0. So I'm going to write 1 over 2 at squared plus v naught t, and then I'm going to add x naught minus x. And so you'll see that it's in this form of ax squared plus bx plus c, and this is equal to 0. So as long as I have it in that form, I can use the quadratic equation, which is negative b plus minus square root b squared minus 4ac divided by 2a. And so now I'm going to plug in my my coefficients here, so you can see that I've underlined those. So this is my a, this is my b, and then this is my c. So I'll have negative v naught plus or minus square root v naught squared minus 4. And then the a is 1 over 2a, so basically it's a over 2. And c is this coefficient right here, x naught minus x. So x naught minus x all over 2a. So 2a is a over 2. Okay, so we can rewrite this as, so t, we can write t is equal to negative v naught plus or minus square root v naught squared minus And 4 over 2 is 2, so we have 2a times x naught minus x divided by 2's cancel out, divided by 2. 2 divided by 2, and we end up with a on the bottom.